Those good at mental arithmetic may have spotted that this transistor, with a collector current of 2.9 milliamps or so, and a base current of around 9.54 microamps, appears to have a current gain of 304, which is almost certainly not the current gain of the transistor that you're using in your circuit. That's because Simetrix is using an average model of BC182 transistors. You can change this by right-clicking on the device after you've selected it. It turns blue if you select it. Right-click and select View Edit Model. That brings up this window. Now you'll see that there are two models associated with this component. One is the global library model, that's the one stored inside Simetrix, and the other one is this local model here, which is editable. You can change this to reflect the behavior of the actual transistor that you're using. Now, Simetrix uses something called the Gummel-Poon transistor model, which, as you see, has a very large number of parameters. These are actually not all of the parameters in the Gummel-Poon model. These are just the ones which the BC546B model doesn't set to the default value for an NPN transistor. It would take an extremely long time to work out what all of these parameters should be for your transistor, so in this lab we're going to simplify it. We're going to remove all of the parameters except IS and BF. BF is one that is going to set our current gain, and IS is one that is going to set the transconductance parameter. It's going to tell you what the relationship is between the collector current and the voltage between the base and the emitter. These, in terms of the equations, reflect this. If I click OK, after making sure to select Use the Local Model, let's set BF equal to 200. That gives you a current gain of 200. I'll hit OK, and then rerun the simulator, and you'll see that the currents have changed. And now the collector current at 1.9 milliamps is 200 times the base current of 9.54 microamps or so. By taking the measurements of VBE, the voltage between the base and the emitter, and IC and IB, which you can work out from VC and VB for your particular transistor, you should be able to work out the values of IS and BF that you need to use in the transistor model to reflect the characteristics of the transistor that you're using.